What's up guys? In this video we're going to go through the Hungarian algorithm. So in this situation we've got Alison, Bob, Charlotte and David. They need to be assigned jobs and the jobs are W, X, Y and Z. In this matrix here it shows you how many minutes it takes for each person to complete each job. So step one of this process is something called row reduction. Row reduction is just subtracting the smallest value in each row from all other values. So for example, in row A, the smallest value is 75, so that's going to be subtracted from everything in that row. In row B, the smallest value is 60, so that's going to be subtracted from each value in that row. And we're going to do the same for row C and for row D. So once we do that process, this is the matrix that we get. Now step two is something called column reduction. So we just did row reduction, now we're going to do column reduction. And column reduction is just subtracting the smallest value in each column from all other values in that same column. So I've written down the smallest values here. So I've written down the smallest values at the bottom here, and I've gone and taken those values away from each element in that column. And this is the matrix I get. Now this is really important. So row reduction and column reduction can be done in any order. So if I had have chosen to do column reduction first and row reduction second, it would have been fine. Some of my values along the way might have changed a little bit, but my final answer would be the same. So you can do row reduction or column reduction in any order, it doesn't matter. Now what we need to do, this is where it starts to get a little bit more complicated. We need to try to cover all of the zeros in this matrix in the least number of horizontal or vertical lines possible. So I've just tried to do that here, and notice I can cover all of the zeros in 3 lines. So only 3 lines are required to cover all the zeros. However, we need 4 lines minimum, given that this matrix is a 4x4 matrix. So for that reason, we've got to go on to step 3. Now step 3, where it gets a little bit complicated, is to subtract the smallest uncovered value, right? So notice some of these values are uncovered, right? So like the 20, the 35, the 20, the 35, the 25, and the 10. 6 of these values are uncovered, right? So we've got to subtract the smallest uncovered value, which is 10, from the other uncovered values. So it doesn't seem too hard. But at the same time, what we've also got to do is we've got to add that smallest uncovered value, which is 10. We've got to add that to any value that is covered by an intersecting line. So that number there, number 10, we're going to subtract that from each of those values because they're uncovered. We're just going to subtract 10 from each of those. Then we're going to add that 10 to these values here that have intersecting lines. Now that we've done that whole process, we've subtracted 10 from the uncovered values, and we've now added 10 to the covered values with intersecting lines. Now what we need to do is we need to check again and see if we can cover all of the zeros in 4 lines minimum. And in this case, now there's no option. We have to use 4 lines in order to cover all of the zeros. That means that we can stop here. Now we're ready to assign tasks using a bipartite graph. But just before we do that, if for some reason, and this is so rare, I don't think I've seen it happen once in any question that I've done within general maths, if you still can't cover all of the zeros in 4 lines, then you just have to repeat the last step. So you cover as many zeros as possible and repeat step 3. And you keep doing that until you can cover all of the zeros in 4 lines. Now we're ready to assign these tasks using a bipartite graph. So notice we've got A, B, C, D on one side and W, X, Y, and Z on the other side. Now we're going to draw a line connecting the person with the job depending on where the zeros are in the matrix. So notice there's a 0 with A and W, so I'm going to draw a line connecting those. Then there's also a 0 in the A, Y value, so I've joined a line from A to Y. I notice that there's a 0 in row B, so B can do job Z, and we're just going to basically keep repeating that process for all of the zeros, and this is what I get. So this is called a bipartite graph. Now I need to problem solve a little bit based on this bipartite graph. So looking at this, right, I can see that A can do W or Y. However, A is the only person that can do W. So for that reason, A has to do W. There's no choice. Now, if I look at person D, right, they can only do Y or Z. But person A could have done Y, but he's doing W. So that means that person D has to do Y because otherwise no one else can do Y. And so person B can only do Z. So person B has to do Z, which means that person C, therefore by default, has to do X because Z is already taken. Now, to find the minimum completion time, we've got to refer back to the original matrix at the beginning. We've now assigned our tasks, right? So we know that A does W, which takes 100 minutes. We know that B does Z, which takes 60 minutes. We know that C does X, which takes 75 minutes. And we know that D does Y, which takes 135 minutes. When we add up all of those times, this gives us the minimum completion time, which ends up being 370 minutes. In the next video, we're going to go over how to figure out the maximum completion time. So this video is all about how to find the minimum completion time when assigning tasks based on knowing how long it takes each person to complete each task. Next video is going to be about finding the maximum completion time.